The Yang-Mills existence and mass gap problem is one of the 7 Millennium Prize problems, for which the Clay Mathematics Institute offers a $1 million prize for a correct solution. It's a deep question in quantum field theory, a branch of theoretical physics that seeks to describe the fundamental forces and particles in the universe. To understand the Yang-Mills existence and mass gap problem, we first need to understand a bit about quantum field theory. In quantum field theory, the fundamental entities are fields, which are quantities that have a value at every point in space and time. Particles, like electrons and photons, are seen as excitations of these fields. Yang-Mills theory is a particular kind of quantum field theory that is used to describe the strong and weak nuclear forces, 2 of the 4 fundamental forces in the universe, the other 2 being gravity and electromagnetism. In a Yang-Mills theory, the fields are associated with certain mathematical structures called Lie groups, and the particles are associated with the gauge bosons of the theory, which are the force-carrying particles. The Yang-Mills existence and mass gap problem is actually 2 related problems. The first part, the existence problem, is to rigorously construct a Yang-Mills theory in 4-dimensional spacetime. While physicists have been using Yang-Mills theories for decades with great success, particularly in the Standard Model of particle physics, they typically use approximate methods and ignore certain mathematical difficulties. A rigorous construction of a Yang-Mills theory would put these physical theories on a firmer mathematical footing. The second part of the problem, the mass gap problem, is to show that the gauge bosons in a Yang-Mills theory have positive mass, even though the classical theory ignoring quantum effects would predict that they have 0 mass. This is known as the mass gap, because it means there's a gap between the 0 energy of the vacuum and the energy of the lowest energy particle. The existence of a mass gap is a key feature of the strong and weak nuclear forces as we observe them. The Yang-Mills existence and mass gap problem is a difficult and deep problem that lies at the intersection of mathematics and physics. Solving it would not only have big implications for quantum field theory and our understanding of the fundamental forces, but could also lead to new mathematical techniques and insights. Despite many years of effort, it remains unsolved.